What's up, everybody? Mr. Cozed back again with another video lesson. This time, our topic for today is a calculus lesson on volume. We are going to talk about rotating solids and creating solids by rotating over the y-axis. So I've already done a video on rotating over the x-axis. If that's what you're looking for, go watch that. The link to that video is in the description of this video. Check that one out probably first, and then come back and check out rotating over the y-axis. Okay, so no matter where you are or how you found this video, I got to tell you, today's a great day to be alive. I'm happy that you're here, whether you're here because you want to be or you have to be. Man, I hope that this next little bit of time is meaningful and impactful for you. I hope it helps. If it's helpful for you, please let me know. I love hearing from you, whether these videos are working, whether they're not working. I definitely want to be a TP, a teacher of the people. So if you would, let me know if you like, dislike, whatever. Let me know so I can always make it better for you. Okay, so grab something to write with, get something to write on, and let's get after it. So same directions as what we would have had in the rotations over the x-axis, but if you're brand new for this lesson, here you go. You'll be asked to sketch the figure and find the volume when the given area is rotated about the y-axis. Every problem we're going to do today, and we're going to do 4 problems, is going to be created by rotating an area over the y-axis. Okay, so step number 1 is to draw a sketch of this graph. Let me get that here. Let me get this one. There we go. All right, so we're going to draw this a graph of this function. Okay, so let's see. So I have got 1/2 x is a linear function. So that's going to be a line that looks something like this. Okay, x equals 0 is right here, and y equals 1 is right here. Okay, so what we have is we have a little right triangle here. Okay, and what we're going to do is we're going to take that right triangle and we're going to rotate it across the y-axis. So when I do that, I'm going to end up getting a 3-dimensional figure that looks something like this. And again, I like to show the rotation. It's not perfect, but I like to show the rotation at the top to show that it's almost like a cone. This, in fact, would be a cone that we are rotating. Okay, so just like we did in the last one, we're going to find the area, the volume, by finding the area of a cross-section. Okay, so what does one of these cross-sections look like? Well, if you watch the first video on rotating over the x-axis, you know you have 2 choices. You either have a disc or you have a washer. So in this particular case, since we're rotating across the y-axis, okay, if you look at this graph, notice there's no space in the middle or along the y-axis. Therefore, this is going to be a solid shape. So we have a disc. We have a disc. Now, the next step is very similar, but instead of doing the area with respect to x, we're actually going to do the area with respect to y. So that is one little change. Now, the area formula of a circle, that does not change. But let's think about what the radius of this circle equals. Okay, so if you look at the graph, your radius is this distance right here. Okay, so your radius is that distance right there. So what I really need to figure out is I need to figure out the x value of this point right here. Okay, so the way that I'm going to write that is that the radius is going to equal x. Now, what does x equal in this problem? Well, you see the equation here is defined for us, y equals 1/2 x. So if I take this 1/2 and move it to the other side by multiplying, I get that x actually equals 2y. All I did is I rearranged that function, okay? I rearranged that function to solve it for x, which you're going to do a lot of that when you're rotating about the y-axis. Okay, so to find our actual area of that cross-section, we plug 2y in for our radius, and we square that, okay? So then I get the area equals pi times 4y squared. Pi times 4y squared. And that actually is what we're going to integrate. Okay? So now the other change here is for our bounds, our lower and upper bounds, we're going to integrate with respect to y. So we're going to be looking at the y-axis. Okay? So my lower bound is y equals 0. and my upper bound is y equals 1. That was defined for us in the problem. Okay, so we're going to integrate this. So we have pi times 4y squared, and we're going to integrate with respect to y. That's another change from the last lesson. Remember, we're going to integrate with respect to y. So easy integral to figure out. This is going to be 4 pi times 1/3 y cubed, and we're going to evaluate that from 0 to 1. So plug a 1 in for every y that you see, get a number, and then plug 0 in for every y that you see, and you're going to subtract those two numbers. So when your lower bound is 0, that's really, really easy, because when you plug 0 in here, you're just going to get 0. So when I plug 1 into this integral, I end up getting 4 pi over 3 units cubed. 4 pi over 3, 4/3 pi units cubed. Okay? Again, before we move on, just to note, a couple changes. Now we're integrating with respect to y, and when I found my upper and lower bound, I'm using the y values, okay, not the x values anymore. That's changed because we're rotating across the y-axis. Okay? Question number 2. All right, y equals x cubed, y equals 1, y equals 8, and x equals 0. So first step, as always, is to draw a coordinate plane. Okay. All right, so let's graph these functions. So y equals x to the third is like this squiggly little line that looks like this. Whoops, wrong tool. Sorry about that. Squiggly little line that looks something like this. Y equals 1 is a horizontal line that looks like this. Y equals 8 is going to be a horizontal line that looks like this. And x equals 0 is this line right here. So pretty clearly we can see that my the area that I'm going to be rotating is right here. Okay, I'm actually going to erase this little branch down here just so it doesn't get in our way. Now we're rotating across the y-axis here. Okay, we're rotating across the y-axis. So when we do that, we've got something that looks very similar to this. I don't know about you, but I kind of like drawing these pictures. Okay, we get a shape that looks something like this. Now, if we look at our cross section here, let me make that a little bit bigger. If we look at our cross section here, okay, and you ask yourself the question, is this going to be a disc or is this going to be a washer? Okay, again, what you look for is you look at the y-axis, and there's no hole, there's no space. The shading is right next to each other, okay? So this is going to be a disc, okay? And the area of a disc is pi r squared, where we need to figure out what r equals, okay? Now, remember, r is your radius, and that's going to be this distance right here. So that distance means I need to find the x-coordinate of the point along this curve, okay? So for here, r equals x, and x, you have to be really careful with this, okay? If you solve this first function, y equals x cubed for x, you end up getting that x equals y to the 1/3 power. You take the cubed root of both sides. So when I plug that value in for my radius, I end up getting pi times y to the 1/3 squared. And if we apply some algebra skills, properties of exponents, we end up getting pi y to the 2/3 power. So then what I'm going to do is I'm going to evaluate that integral. And remember, we're going to use the y values. So I need to find this y value and this y value. Oh, sorry about that. Hold on. There we go. So y values, my lower bound is 1. And my upper bound is 8. So we're going to integrate this from 1 to 8. Okay? And the area formula that we found for one of the cross sections is pi y to the 2/3 dy. So when we evaluate this integral, pi is a constant. The exponent is going to become 5/3. So my constant that I'm going to multiply by is 3/5. So 3/5 y to the 5/3 evaluated from 8 to 1. Again, this one's a little bit more complicated because you're going to actually have to plug in the upper and the lower bound since the lower bound's not 0. You're going to have to plug and chug. I'll let you do that. Again, this isn't the video for me to show you how to find solve definite integrals. You should be able to do this at this point if you've made it this far. So 8 goes into y, get a number. 1 goes into y, subtract from the first part that you got, and you should end up getting 93 pi over 5 units cubed is the volume of that shape that's created when we rotate this area around the y-axis. Okay? Okay, next problem, number 3. Same first step that we've had pretty much every time. We're going to draw a sketch of the graph. Okay, so I've got x squared, which looks like this. That's not what I wanted. X squared looks like this. Y equals 0 is right here, and x equals 2 would be something like this. So the area here is right here. It's like this little triangle with kind of like a curved side. So if we rotate this across the y-axis, and I draw a sketch of what that other side's going to look like, it's going to look something like that. Again, I like to show the top part as being rotated as well. It helps me kind of visualize the shape. Now, if we draw a cross-section here, okay, if we draw a cross-section here, you can very clearly see that there's a big gap here in the middle. There's a big hole, okay? So this cross-section, if you paid attention to the last video, okay, this cross-section is not a disc anymore. This is going to be a washer, okay? And I'll draw that for you here. So remember that a washer is a hole, a circle with a hole in the middle, okay? It's a circle with a hole in the middle, like this. So these, if you watch the last video, finding the area of these is a little bit more complicated, but we can do it, okay? So the area of a washer is the area of the big circle. So the way that we did that is we did pi r big, so the radius of the big circle, squared minus pi r small, the radius of the small circle, squared. So now the hardest part is figuring out what is the big radius and what is the small radius, okay? So if you look at the graph, okay, the big radius is always going to be this vertical line. So it's always going to be x equals 2 as the radius. So that makes finding the area of the big circle really, really easy. It's always going to be the same thing, pi times 2 squared minus pi times the radius of the small. Now the radius of the small is this inside part right here. So for that, I need to find the x-coordinate that's produced using this function. So that means I need to take y equals x squared and solve it for x. So that means that I'm going to take the square root of both sides, and the radius there is going to be the square root of y squared. Now if I clean that up, I end up getting 4 pi minus pi times y. So that's what I'm going to integrate, okay? So I'm going to set up my integral here. For the upper and lower bounds, remember using y values. So the lower bound is clearly 0. And the upper bound, I'm not sure about. I don't know what that y value is. But I do know that the x-coordinate here is 2. So if I plug 2 in for x in the function y equals x squared, I very easily get 4. So my upper bound here is going to be 4. So we go from 0 to 4. And again, that function that gives us the area of a cross-section is 4y minus, or 4 pi minus pi times y dy. So again, these integrals should not be super complicated for us. They should be pretty straightforward and easy. So then we get pi times 1/2 y squared evaluated from 0 to 4. So then here we are, we plug and chug. We put our upper bound in for y, get a number, plug our lower bound in for y, get a number, take upper bound minus lower bound, to figure out our area, our volume of this particular shape. So when you do that, you should end up getting 8 pi units cubed. So our volume of this particular shape is 8 pi units cubed. Okay? One more question to do together, and then we're done. Okay? So here it is. We've got y equals the square root of x, y equals 0, and x equals 9. Okay? So if you're feeling really confident and want to try this on your own, pause the video now and try it. Try drawing the graph. Try finding the area. Try doing everything that you can. And then pick the video back up when you're done. Okay? Well, welcome back, those of you that did actually pause the video and tried it on your own. Those of you that are just like, I want to just get this done. Okay, you stuck with me. So that's great. Let's just knock it out. Okay, so we get the square root of x is a curve like this. X equals 9 is a vertical curve like you see. Sorry about that. Y equals 0 is right down here. Okay, it's a pretty easy shape to see. So our area enclosed by those 3 lines is right here. We are rotating around the y-axis. So that means when I rotate this, I'm going to get a shape that looks almost identical on the other side. And again, I like to show the rotation that happened here. Okay. All right, so very clearly when you draw a cross-section or think about the cross-section, you can see that there's going to be a big hole in the middle. There's going to be a big hole in the middle. There's space along the y-axis. So what that tells me, this cross-section is going to be a washer. The cross-section is going to be a washer. So to find the area of a washer, remember, we do pi r big squared minus pi r small squared. So let's identify what is the big radius and what is the small radius. So if you look at your cross-section, the big radius is always going to be this length right here. So it's always going to be out to x equals 9. So I can plug that in for the radius of my big circle. Okay. Now the radius of the small circle is the one you have to be careful with, because the radius of the small circle is going to change no matter where I stop. Okay, and it's always going to be found by solving for x in this function, y equals the square root of x. Well, if you think about how am I going to solve for x in the function y equals the square root of x, you simply square both sides and you'll get the radius equals y squared. Now don't forget to square that. A lot of times people will see y squared here and they'll think they're done. But remember that the area formula for a circle is pi r squared. So your radius is y squared. You also have to square that. So if we clean this up, we get 81 pi minus pi y to the 4th. So let's set up our integral here. Okay, so again, we're looking for the lower bound on y and the upper bounds on y. Lower bound is clearly 0. Upper bound, we have to think a little bit. Okay, upper bound, we have to think. So we know the coordinate of this point on the top right, the x value is 9. I know that because it was given to me in the directions. So I have to plug 9 in for x, and I pretty easily get 3 for the y value. So that's what you use for your upper bound. You use 3. So then we take our formula for the cross-sectional area, and we integrate that with respect to y. We get 81 pi y minus pi times 1/5 y to the 5th, evaluated from 0 to 3. And then from here, you are so close to being done. You just plug and you chug and you see what you get. Plug 3 in for y. You can skip plugging 0 in for y because it's going to be a sum of 0. So once we just plug 3 in, we'll get our answer. I'll let you do it. Again, this isn't the right spot for me to show you how to do that. If you do it and you do it correctly, you should have gotten 272 pi over 5 units cubed. Final answer. That, ladies and gentlemen, is how you find the volume in calculus when you rotate areas across the y-axis. I hope this video was helpful for you. If it was, let me know. If it wasn't, let me know. If you're still with me, you made it all the way to the end, you are the real MVPs. You're the people that I love the most. Thank you guys so much, and I will see you next time.